So I see Hemangini, Ishan Thakur, and Vaishnavi Sonsale. Only 3 people here. If you have any questions, you can ask. Hi, Ishan.
Right. Hello, sir. I did post a question earlier, and that
You
link.
post it. Where is the question?
I received the link. If you have to ask any questions, you have to. But I can just ask you right away.
1 second, 1 second. I'll just see. Is the Google response sheet. Nila, is that the one, right?
Sorry, sir.
It's the Google response sheet, right? Yeah, okay. Yeah, I can see the question one from, yeah, Ishan. Yeah, one question from Raja Babu I have. What is the pattern of exam, objective or subjective pen paper type? I think it will be objective type question. And whether it will be pen paper, I think NPTEL, you can look at NPTEL website and then follow the instructions there. Because that will depend on various factors. But mostly it will be online only. That's what I think. But you can check on the website for clear instructions. Next question is from Tejas Rakhonde. So during 6th week 1 video lecture, you said the material with higher modulus will experience higher stress at the same strain level or deformation level. Then that means that material with more modulus will probably lead to higher crack. No, will tend to crack at an earlier time. So as you can see here, this is that case when you have a high modulus, as you can see here. I don't know what it means. Anyway, cracking means it's already post yield, state, right? It's not in the elastic region. So that's probably something to be clear about. Cracking happens. No, it doesn't happen during the elastic stage. So when you talk about modulus, we are talking about the elastic region of the material. Okay, so maybe that confusion is there, and that I think Tejas, if you are there, you can ask, is it clear or not? Because when you talk about modulus, we are talking about elastic region, not the state when the material experience cracking. Okay, that's much later stage. When you talk about the stress, then it will experience a high stress, and then it experience cracking. Low modulus is the answer for 50%. The question would be NPTEL live session. Yeah, this question I will look into that and then come back if there is any. If you can email me or Nila or the TS are here. If we can extract that question number which he is exactly talking about, 8th question in the 5th week assignment, because if I don't remember what the question was, so we can look at it later. Okay. Nila or Umesh, can you just note it down?
Yes, sir.
Yes, sir.
Yeah, okay. And what is the next question? This is like a more of a general career oriented type question. So you can email me directly and then I can comment on that. The question from a PhD student. I don't know the name. It says student who's exploring the concept of infrastructure management. So
That would be me, sir.
that's you. Okay. Okay. So what is the question? Can you can just elaborate, then we can discuss it here.
Sir, I have been looking into infrastructural asset management.
Okay.
And so far, I have diverted towards how we
I
can
cannot
manage
hear
things.
you clearly.
Am I audible now?
Yes, yes.
Okay, so far I've been diverted towards how we can manage things, how we can do this, and which should be done. But nobody's actually explaining how and what needs to be changed right now. For instance, we have for roads, we have IRC 130 that was published in 2020. So that explained how Karnataka has changed its ways, how they are managing data.
Just 1 second, just 1 second, okay?
Yes, sir.
Yeah, sorry about that. Just go ahead, Krishna.
Yes, so my query is that we know what to do and what we lack, but how to initiate, how to proceed with this, how to make rehabilitation of structures mainstream thing right into the design aspect.
Last part I didn't hear it. I heard until how to rehabilitate and then.
Like while designing, why can't we? How do we incorporate rehabilitation of structures right in the beginning, right in the designing stage? So we know that this is the life cycle of this structure, and after so many years, it will need a maintenance or rehabilitation or so and so. So how to proceed with that? How do I initiate?
Yeah, mainly the challenge in with my experience, I would say people may not budget for that. The cost for rehabilitation, during the design stage, I don't think many would be willing to put in money for performing the rehabilitation activities on a structure. So unless, like, even on our day-to-day life also, if we have something, if the whatever, let's say your cell phone, when you will replace the cell phone, or when you go to a shop to change the cell phone or get it repaired, when it becomes very difficult to use. Until then, you will try to use it. Like that, structures also, people will try to use that until it is serving the purpose. When it becomes really unsafe, that is when we have to be careful, and then we should exercise rehabilitation activities. But if you're asking during the design stage itself to budget for it, I don't know if anybody would do that, because you are talking about after several decades, right? Why should I earmark some money now for doing something after I'm dead, even sometimes?
But the cell phone example is.
Yes. Yeah, say again.
Cell phone example is like if you buy a cell phone, you buy a cover immediately, that in case it falls. So why can't we imply the same concept of being a little protective, sometimes overprotective to the
What we are
structure?
putting the safety factor, for example.
Yes.
So we have safety factors in our design procedures, right? So and also, for example, we have safety factors. Then we have concrete cover is there. On top of that, you might also provide painting. All this help in but we don't consider those things in our explicitly. We do not consider them in the design procedure, right? Explicitly, but indirectly somehow all this helps. So that is where sometimes people say, like, when you have even the currently, like, when we say durability or service life, there is an assumption which people use is deemed to satisfy requirements. In other words, we essentially assume that this is going to last for 100 years, not based on some very good tests or anything, but there is something called time testing also, right? Time tested material. So we say, okay, it will last. So some engineering judgments do play a role. So that is where the experience of the persons come into the picture. But still, as I might have told in the classes, that there are several examples where we do think that they will not last or they will not meet the claims made by the builders, the structures, right? Sometimes they say 100-year service life. So my question is, what is the definition of service life? Is it going to last for 100 years without any major repair or not? Can you guarantee that? So recently, one example I can tell, where one of the bridge project, it is only about 8 years old bridge, 8 years old bridge. And I mean, sorry, 8 years, 8 plus 8, 8 plus 3, that is a 11-year-old bridge. But about 8 years, I mean, after the service of 8 years, the bridge started exhibiting corrosion, severe corrosion here and there. And then, and it's on a coastal line, okay? And then they did some conventional repair. And then after 3 years, again, the place where it was repaired is showing corrosion again. And this repair was costing crores of rupees. Now again, just after 3 years of repair, it's again showing problem. So people are now questioning, you know, how do we avoid these repeated repairs? That is where durability of repair materials, that's one of the question also, I think it came up. See, so we have to ask in our tender documents, we have to ask for a design life or a service life of repair. In the tender document, we have to ask. So if you are talking, now we are slowly talking about it, like, you know, you should ask like 25 years of repair free life. I need when you do a repair, the durability of the repaired region should be at least 25 years. You ask for it. So it's always a demand versus supply. When the clients start asking or when they start demanding that, okay, I need this much life, then the industry will provide the solution for it. But if client is not even asking, then industry will not provide the solution. Of course, money is there, right? You know, when you get repeated repair projects, people will make money. See, at the end of the day, every business is it's not charity work, right? You also have to make money. So it's a responsibility of the client or the engineers in charge to ensure that they ask for a target service life of the repair. I mean, this class we will focus on the repair procedures. So that's why I'm not talking about for new structures. I'm talking about the existing structures. When we do the repair, please ask for a minimum service life of the repair. That will make the industry to think, okay, now which solution I should provide. As you brought this up, there is also this, people say L1 is the main issue. I don't know if I discussed L1 in class. Did I discuss L1? It's the lowest cost bid, you know, bid with the cheapest. So generally in government projects, people will have to, you know, go with the lowest bid, right? Yeah, I'll take that question next. In the lowest bid, but my point is, the engineer or the client has to prepare a very detailed technical specification. Then even the L1 will be a good one. And then last week I was hearing, like, you know, in Austria, I think they go for L2, not L1, not the lowest bidder, but the second one from the lowest. So it's an interesting thing, you know. So if you try to keep on reducing the cost, you will not get the work order. So they go for L2. It's so maybe something to try it out. But there are rules which, yeah, it also says called Swiss model. Yeah. We have to see all these different options, which is good, but we have to also follow the rules. So the best thing is do the homework while developing the tender document. Okay. So one very simple example which I use is if you want to buy milk, if you're called in the tender document, if you're saying I need a white liquid, if you say that, you won't get any. You can get rubber milk, you can get cow's milk, you can get goat's milk, anything, and whichever is cheapest, you will be forced to buy if you go with L1. But if you say, I want a white liquid which has this much fat content, which has this much vitamin C, all those detailed specifications, if you write, so that's the job of the engineer. He or she has to write those specifications in detail, do the homework. And if you say performance requirement, first of all, the engineer has to know what is that required performance. And then define a parameter which is measurable and put that in the tender document. Measurable parameters you have to put in the tender document. Not just saying better durability. They are all vague statements. You have to say specific. You know, n number of years, 40 years, 50 years, something like that you have to specify. Instead of saying durable can be like, you know, it's a very subjective in nature, right? So you have to avoid these vague statements and words in the tender, get to very specific, you know, statements have to be considered. And then that's where the engineer have to start doing the homework. You know, engineers should take the responsibility. Then things will work out. Most of the time what happens is, you know, we ask others to provide suggestions. You know, if you ask somebody is trying to sell a product, they will try to sell the product, right? But if you say, give me the product only if this meets such and such requirement, then the choice will decrease. Number of items which you can use will decrease, and then L1 will not be a serious issue in that case. Most of the time where L1 becomes, or people start thinking that it is not a good solution, is when you don't do real good homework on defining the technical specifications for tender. Okay, so I'll take this question. I don't know if I answered your question very clearly. I don't think I answered very clearly, but what you're asking is, can we incorporate rehabilitation in the original design? See, the original design is for a particular life. Rehabilitation will come after that life. Maintenance is a different story. Maintenance you should definitely include, because that is within the design life. But rehabilitation is probably after the design life. So that's a little difference between the two. Yeah. So I'll take this question from Prabhu Vasudevan. In waterproofing barrier system, in negative barrier, the water is already ingressed into the concrete structure. Then how can we say that it is a barrier? Yeah, it's already into the concrete structure, but we don't it's already inside the concrete element. No, it is not allowed to seep into the open space on the other side. That's the idea. So that's why we call it a barrier. Barrier means it is okay to be in the concrete element, but it should not seep through and come out of the concrete element on the other side. Nick, I don't know if Nikhil, sorry. Okay, this is from YouTube. Any other question from anyone?
Yeah, good afternoon, sir. This is Ansar from Andhra Pradesh, Vijayawada.
Yeah, I answer.
Actually, as you just in the discussion, I come across that the client has to define for a certain period of extension, like how many years it is going to retain and what is the methodology it has to develop from the industry. Then we can able to come across. So, based on the repair rehabilitation techniques, that is that possible to define a period on that? Like it will retain for 5 years, 10 years, or 50 years, whatever it is. So is it possible to define like period on what basis we can able to define the period on that?
Period of what?
Period on sustainability. Whatever the repair rehabilitation works we have been doing, as in the earlier discussion, I think answering to Mr. Ishan Thakur, you have replied that the client has to define for an time period so that the sustainability can define to, then the industry will work out for that time period to establish that sort of solution. So is it really possible to define a period for any rehabilitation work what we do?
It is definitely possible. Why it is not possible? See, the thing is, if a particular system, when you are installing, what are your what is your position right now?
I am an entrepreneur and I look out for a third-party quality control testing laboratory at Andhra Pradesh, and as well I am doing my MTech instructors.
Okay. See, the thing is, when a particular repaired system, if it has to degrade, okay, there has to be a mechanism behind which it is degrading, or because of which it is degrading, right? The degradation mechanism.
Right.
So one has to understand what is that degradation mechanism, and the new system which you are going to put in, is it going to really take care of that degradation or not? Or is it going to stop that process from happening or not? I'll tell you one example. Okay. In the slides also we have provided something where let's say you are talking about an concrete on a bridge. Okay. Bridge, or the joint between or right above the pillars, where there could be vibratory loads.
Okay.
Okay. Or even impact load, because there will be, like, when the vehicle goes from one slab to the other, there is a little impact which is experienced, right?
Right.
Now in that concrete, if you want to replace, first thing, let's say already the concrete has cracked. So an engineer should go and see what is the reason for that cracking of the concrete. Mostly it will be this impact loading or vibration or something of that nature, right?
Right.
Now the new concrete, if you're putting, if that new concrete which you're going to put doesn't have that impact resistance or toughness or sufficient toughness, then what's the point in replacing that with? There's no point, right?
Right.
And if the owner knows that, in the past, every 1 year or 2 year, whatever, and this was keep on happening, they were keep on replacing with this new concrete, it cost a lot of money. Now owner has to tell that I want to do the next repair I want to do, and I don't want to do it again for another 20 years. Okay. So the owner has to make that choice. I want to do a repair which will not crack because of this impact load or vibration for another 20 years.
Okay.
Now, when the owner says that I want something for 20 years, then the concrete manufacturers will start thinking what type of concrete I should provide. Now, what I see in many places is people just put micro concrete, wherever possible micro concrete. It is not going to solve the purpose, because you have to think about the toughness of the concrete and not the compressive strength of the concrete.
Toughness compared to compressive strength, how will you define, sir?
You don't have to compare. It is different property.
Okay.
Okay. I think we've already covered this in the, if you look in, other courses, you will definitely see what is on toughness. Toughness is basically the capacity of the concrete to absorb the energy. So when you have impact load, it will absorb, but it will not crack, or the crack opening will not happen. It will not, concrete will not crumble down. You have fibers, for example, if you use fiber reinforced concrete, it will not crack. I have examples on this because recently we did a bridge project on which, just as an for some places where this kind of cracks were there, we put fiber reinforced concrete. So some other places we put just regular plain concrete. Very clear, the plain concrete already degraded in just few months. Whereas,
so can we say that this is a resistance to break the concrete?
Yeah, so when you say breaking, when you have impact load, there is some energy transfer being happening, right? Energy.
Yeah.
So if the concrete can take that energy or that shock without getting cracked,
Okay,
or without getting crumbled down, then that energy absorption capacity is more important to consider than the ultimate compressive strength of the concrete. So one has to decide which is the property which is degrading, which is the property which is related to the degradation mechanism, and that property has to be defined.
okay.
Okay. If it is failing because of heavier loading,
Right.
then probably you have to look at compressive strength, and not. But if it is because of impact load or vibration, there you might want to look at toughness also. So you have to see what is that degradation mechanism, whether it is mechanical or environmental load, doesn't matter. What is that degradation mechanism, and then what property is more important to consider? Consider that property. So some homework needs to be done, and then so when people will start doing this homework is when the tender document specifies these things. And you attach money to it. You say that, if you have, if the concrete fails before a particular time, then there will be penalty,
Right.
So if you include those kind of clauses in the tender, things will, people will work out. See, it is not that we don't know the solutions or we don't have the solution. We do have the solution, but we don't really, in most cases, we don't get into the details. We have to get into the details and then do it. So for example, if it is vibratory type load or vibration, you have to look at how many cycles will be there, how many vehicles are moving on the bridge, what is the amplitude of each load cycle, things like that you have to look at. So that job has to be done by the engineer, and then decide I want this much life for my structure or for the repair work. That's how we define the durability. Now this is a mechanical load example I just mentioned. Let's say you're talking about waterproof. Okay. If the the major degradation mechanism is UV radiation, UV induced degradation. So what you have to do is you have to either make sure that in the tender document you specify that the UV resistance should be this much. And then you have to also probably suggest, as per so and so test, the material should have so and so properties. So some specifics have to be worked out. Or what you have to do is somehow make sure that the material or the polymer which is used doesn't get direct sunlight. You can provide another layer on top which prevents it from getting direct sunlight. So these are different things. But if you do not even specify UV resistance in the tender document, then what will happen is every other year you will have the waterproofing work will keep on coming again and again. I've seen this in many places. That's why this thing came into my mind.
Right.
And also sometimes people will claim, okay, this will last for 10 years, 20 years. So you have to ask how, what is the mechanism behind that, or on what basis you are telling that it will last for 10 years or 20 years. Because most of the time, when you say 10 years, 20 years, by that time, even if something goes wrong and you find You may not be in a position to find the supplier and then do something about it, right?
Right.
It's too late. Maybe the company may not exist also.
Right. Absolutely.
These are the problems, so the real life problems.
So when we come across with
This has
the
to be brought into, so in case of this UV resistance, when you talk about waterproofing, you have to say, as per so and so accelerated test, this should meet these requirements. So that's where our engineers, we have to be more, we have to do our homework before we approve the purchase of a particular material.
Generally, I come across with the verification of structural, soundness test here. So in that case, normally people will ask for the how much life is additional, it will be there or it will be good enough. So in that case, how we can, as an engineer, how we can able to define the period, lifetime of the structure based on what dimension? Because physically we can able to verify the dimensions and reinforcement and whatever, reinforcement condition that I can able to assess. And based on the integrity and based on the.
Who is speaking actually?
This is answers.
Okay.
I will just show.
Answer Babu. Okay.
Yeah.
It will be good if I can see you also. Yes.
Yeah. Okay. So in that case, how we can able
Otherwise,
to
I feel like talking to computer.
yeah. Got through. So in that case, how we can able to assess a building, because physical testing, whatever it is.
What I would do in the first, I'll keep a general thing. What I would do is first look at where the structure is standing.
Right.
And then look at what are the mechanical loading which is coming onto the structure.
Okay.
And what are the environmental loading which is coming on to the structure.
Okay.
Mechanical and environmental.
Right.
So all these loading which we talk, even chloride exposure, carbon dioxide, we can say it's a chemical loading, right?
Right.
So mechanical and environmental conditions can be looked at. And if somebody is asking, okay, how long this structure will last, you have to first see whether those mechanical loads are severe or not, or what, assess the influence of that mechanical loading on the structure.
Okay.
One thing is you can just take static loading and all that, and then whatever the loading conditions, and then look at the actual compressive strength of the concrete, not the concrete as per the specification, but the actual. Okay, actual compressive strength. And if you have steel reinforcement, then you can say, okay, basically looking at the load rating of the structure.
Okay.
Or what is the structural capacity assessment is what is not the design procedure, but you are assessing the capacity of the structure and whether that is be above the applied loading conditions or not.
Okay.
That's one. Now, if you're talking about durability and other things, then you can look at what is the chemical resistance of the concrete.
Okay.
Because I'm thinking here, environmental conditions, when you say maybe temperature is one factor, and then moisture conditions is another, chloride, carbon dioxide, sulfates, etc.
Right.
So which chemical is present there, you have to find.
Okay.
And if that particular chemical is present, what can that chemical do to the concrete?
Right.
So if it is chloride, if chlorides are present, or if you're anticipating that corrosion is going to happen.
Yeah.
In the structure which you were talking, which is the type of degradation mechanism you were thinking?
Chlorination, actually.
Chloride induced corrosion.
Right.
The first thing what I will do is I will take a core from the cover region of the concrete element.
Right.
Why I'm saying cover region is because the moment you say I want to take a core, the structural engineer will kind of ask, there is a hesitation in taking a core from the column, right?
Right.
So what you tell is, you tell that take it only from the cover region, which is not considered in their design procedure.
Right.
So then they cannot say there is any safety reasons, right? I mean,
Right.
there is no safety concerns. So you can take the core, or rather a disk. Don't use the word core. Use the word disk. You take a 20 mm deep disk, like you core it, but call it disk.
Okay.
It's like a disk only, no? So you take that from the cover region,
Right.
so that getting approvals and or permissions are going to be easy. Then you do a chloride test on that. Find out chloride profile. What is the amount of chlorides present at different depths, and are they very close? You know, what is the chloride available very near to the steel reinforcement, etc.
Okay.
Okay. So then you can, based on that information, you can decide what will be the remaining life.
So from
We are
this
able to get this chloride data. At that time, we can talk further and then we can work on more.
okay. So general opinions, from this rebound and I mean
And the
UPV
people
and other.
here in the class, I'm writing my phone number. So if you want, you can note it down. Yeah. And actually, I have created a WhatsApp group. I don't know if all of you are joined in that.
No, sir, I am not there.
Huh?
I am not there, sir.
Yeah, but we have been sending invitation, but nobody's.
Oh, sorry.
Right? I think Umesh has been sending invitation, no? Right, Umesh?
Yes, sir. We'll add the new.
So maybe you can send one invitation today also.
Yes.
Yeah.
So based on the, I mean, homogeneity of the concrete and as well with reference to the rebound test, what we do, and with chlorination. So based on these combination, I don't think we can able to assess the life and the life of a structure. I don't think so.
No.
This is the mechanical properties what we are.
Yeah, mechanical properties are different. Durability properties are different. If you are talking about durability, like, see, there are two things. One is accident, other is cancer.
Yeah.
Right?
Okay.
Like
right.
earthquake, for example, I would call it like an accident.
Yeah.
It
Agreed.
happens suddenly, but if you're talking about corrosion, it's like a cancer. Very slow process, but once it reaches beyond some level, then it is difficult to repair. But if you identify that at the early stages, you can actually maintain the structure for a long time.
Okay. So sometimes I practically whatever, sir, can I discuss? I am just being very leisure.
I gave my phone number, so you can call me later.
Yeah.
Maybe better for others.
Yeah, right. Thank you. That's it from my end. Okay.
See, I think if you ask us to add to your WhatsApp, it will be difficult for Umesh. So it is better that Umesh, can we paste the link here?
Yeah, else I will just
Invitation, I don't know. You can see, I don't know, somehow.
Yes, sir. I will come.
Because otherwise everybody will ask Umesh to add and it will be a lot of job for Umesh. Yeah, anybody else have any question? Okay, if others don't have any question, answer, you can ask. We can continue.
So I come across with a practical problem at one of the hospitals at Andhra Pradesh, where I see one of the footing has been, it is under settlement, and this is majorly 2 blocks of building.
Switch on your
1 second.
Yeah.
So this is a 2 blocks of building where one block is a little bit, G+5, and it is almost around 70 meter by around 15 meter approx, and another one is around 8 meter by around 15 meter. It is in form of L shape, we can say. So these two, what they have done earlier, because it is an hospital to transport the beds from one area to another block. So they have interconnected these two blocks with some ISMB girders, the intermediate platform to connect to have a transportation facility or for the trolley facility. So after some years, they come across with the problem that they are finding the settlement at one block of the building at one edge only. It is not the complete building. One edge, at least two blocks I have identified. I have practically visited, and I see that there is a completely crack under the bottom area of the footing area, and it is a sandy belt where it is situated. So in that case, what physically which come into my mind? Actually, this question I am posing to you to assess the durability point of view. I'm just asking this because there everything related with the practical issues and mechanical link-ups. So what I have got with the solution, not the solution, what the problem is. First, identification is the, identification of problem is the major one. So what I come across with the problem is the interlink between the two blocks, which is having with ISMB girders, and that is a fixed, fixity they have made. There is no cushion or gap in between.
What
the
is ISMB girder? I don't know this.
Indian standard medium beams.
Okay, okay.
Steel beams. So
anyway,
then
you are a steel girder basically.
Yeah, steel girders in between. So what comes into my mind is whatever the lateral deformations which is happening in the big building might be that is influencing the second one. So where the foundation is going, because that connection is at the exterior end of the building only. So that might be influencing this foundation to have an penetration into the ground because of the forces what is coming from the lateral building movement. Because obviously it is G+5 and definitely there will be some lateral movements into it, which is not allowed by this restriction of this steel girders. So it was directed to disconnect it.
This is not a durability related issue, right?
No. Whatever the solution I have given, I just want to understand if they ask me how it will retain for how many years. So based on that,
No,
whatever the solution I have given.
It's not a degradation process.
No, it is not a degradation process.
Yeah, it's a damage process, right? Damage means, again, like the example which we talked about, accident and cancer, right? One is time-dependent phenomenon. The other one is you are applying a load.
Right.
Instantaneous action.
Yeah. So after the after the suggestion,
maybe we can, I have some questions over here.
Please go on, sir. Please go.
Related to the class. But this, I would say, first of all, you have to think about, because I remember Professor C.V.R. Murthy's lectures on where, these L-shaped buildings, you have to consider them as separate things, especially for earthquake. You cannot really connect everything which is probably not good, right?
Yeah, that's what they do. Actually, they have connected it. And once when we are disconnecting it, it's a huge wave of sound what we have observed. Actually, it makes a fear into the very much a big sound it has been created during the time of disconnection, because a lot of stress is there induced in it. And after disconnecting, we feel that difference. And afterwards, we have increased the foundation area where it has been sinking completely, because ultimately we cannot lift the building finally. So further settlement only we have restricted to maintain. So that anyway, that is fine now. But the only thing is I just want to consider where it was and durability point of view, or how this practice will sustain for how many years, how we can able to define on the.
See, what you are talking is not a durability problem.
Yes, not durability.
It's a mechanical problem.
Right.
Or inappropriate structural system.
Might be, yeah.
So that is not.
Disconnecting is one of the factors. Whatever the settlement has happened, so further it should not be, because already the nature of the soil has been disturbed now. So there is some settlement what we found. So I have made it at least 2 meter by 2 meter excavation from one footing to another footing, and completely it was made as a raft, so that the contact area can be increased and the further settlement can be restricted. So that was the thought which comes into my mind, and I have given the solution. So far as they are good and fine, but the time factor.
You can monitor. You can continue to monitor whether is it still settling or not.
Yeah.
And then that will probably help you, you know, instead of just waiting, just continue to monitor and then see if
So
something.
that was there, sir. From there, because obviously they are occupied and they are utilizing the space. They are comfortable now, I think.
I think I have some comment about this. Nikhil is talking. Nalgonda region, we have fluoride in water and hence water used for construction. We can have corrosion like chloride. But I don't know if fluoride will lead to corrosion. I do not know about it. Any other question? No more questions, I think.
So,
To answer, you can call me later. We can have more detail. But before you call, send some email with some photographs or
Yes, sir, I will do
layout
that.
of the building, which will help in better discussion.
Sure, sir, sure.
Because right now, whatever you said, I was imagining things.
No, I'm having the photographs.
Yeah. So you can WhatsApp me the photograph or
I will do
email
that.
me and then we can discuss.
Sure, sir.
Yeah.
Thank you.
sir, there is one more question from YouTube. I've just posted it. The person is asking, I've already questioned checkouts. If water is not allowed to let out of concrete in negative barrier.
I cannot hear you, Nila.
Sir, can you hear me now?
Not very clear. Say it again.
Sir, there is one more question I've posted in chat box from Prabhu Vasudevan.
You can maybe share your screen.
Okay.
So we can see it clear. It's in the YouTube. I can open that also. I cannot see anything.
Hello. So can you hear me?
Hello.
Sir, is the screen visible now?
Yeah, this is water is not allowed to let out of concrete in negative barrier. Won't it create damage to concrete structure? See, this depends on, we will prefer the negative barrier only if positive, waterproofing is not possible. That, I mean, most of the time, positive waterproofing is preferred. Now, your question is, in negative barrier, won't it create damage to the concrete structure? Yes, it will create damage because if you have water inside the concrete, it is not good. It can lead to leaching, and also, you don't want the concrete, reinforced concrete especially, you don't want it to be soaked with water. Okay, so yes, it is not always good to go for negative barrier, but positive waterproofing is always better. Yeah, you can stop sharing, Nila. I think I'm also opening this.
So the next question is, when do we use aluminate cement and when do we use pozzolanic cement?
Waterproofing is always better. One question, when do we use aluminate cement and when do we use pozzolanic cement? Okay. So see, depending on what type of resistant. So if you're talking about acid attack and all that, this calcium aluminate cement is preferred. And pozzolanic materials are also found to be resistant against such attack, but you have to see which type of degradation. Again, I'm coming back to the same thing. All these we cannot really give a generalized answers. You have to identify what are the specific exposure conditions which you have for the particular type of structure, and then accordingly we have to decide which cementitious system to use. Okay, so it's not correct to give a very general answer, because it depends on what is the specific application, what type of chemicals are this concrete going to be exposed to, and for that exposure, what is the target life which is required, and for that target life, one has to decide what type of cementitious system to be used. Okay, so all these have to be brought into the design process. Exposure condition, how long you want the structure to last, then you decide the type of material to be used. Both have to be considered, not just the exposure condition. Now, our side, we have come across a problem that we have done expansion joint treatment for a building roof, but all time cracks are forming in the joint. This has been repeated several times. What is the best solution? So again, best solution is provide a material which is having very good elongation. So you have to see, I mean, maybe getting some photographs again, like I said earlier, would be helpful. But what you have to see is, it looks like there is a movement of the joint, right? So if it is an expansion joint, mostly you should go for a elastomeric material, or you can even provide a layer on top which covers the expansion joint, and it has sufficient elongation. That's the key property, I think, in your particular case. Probably the major property which is required is that the material which you're providing as a protective layer should be able to expand sufficiently without getting cracked. So you have to look at that property. So nowadays such materials are available where they say expansion is 200%, 300%, etc. like that. So that's something which you have to look for. Yeah, I think if you don't have any more questions, we can close this. If you have any more questions, please type it right away so that we can take it up. So in this particular discussion on this, the expansion joint treatment, if you're providing a waterproofing layer, in addition to asking the tensile strength, etc. of that layer, you also have to demand a minimal expansion, percentage expansion. That's also something important to specify. Then you will get a good product, and then hopefully it won't crack again. Any more questions? So if not, we will meet again after about a month, just before the exam. So, or you can also feel free to continue posting your questions in the forum, and I hope you're getting answers. Okay, thank you all. Any more questions, Nila? Can we close?
Yes, sir,
No, we cannot get previous year's final exam questions.
We can proceed.
Don't study for just exam oriented. Just try to understand the concepts, and if you understand the concepts very clearly, you will score very well. Okay, and it's not just scoring in the exam. The real exam is the practice. right? So, yeah. Anything else? Okay, thank you all.
Thank you, sir.
Thank you,
So
sir.
please join the WhatsApp group
Yeah, join.
and we can have all these discussions there. Actually, the group they have people from the previous batches also. So it's really an interesting group. Okay. Thank you.
Good day, sir.